Welcome back, everyone. We are starting conics in chapter 7, and our first conic is going to be called a parabola. These are usually quadratic functions. I should say the graph of a quadratic function. And so there's four basic conics. There's circles, ellipses, parabolas, and hyperbolas, and we will deal with each of those. We can skip to here. A parabola that we're going to study today is a set of points in a plane equidistant from a fixed line and a fixed point. Let's describe what that means. The fixed line is called the directrix. That's down here. The fixed point is called the focus. So that's right here. Now, the line through the focus and perpendicular to the directrix is called the axis of symmetry. That's right down the middle here. The intersection of the parabola with the axis of symmetry is called the vertex. So vertex is down here. It's actually on the graph. So this is the actual graph of the parabola. The focus, let me talk about that just for a moment. The focus is really quite amazing. In eyeglasses, the focus is right. It focuses the light in a certain way to help your vision better. It's hard to do without being live in person explaining this. Also, the focus is, so any signal that comes and hits a parabola, it always goes back up through the focus. So satellite dishes are there, and then the focus is where the arm is, so that all the signal bounces off the parabola and goes into the signal. So lots of uses for this. And we're going to go a little bit more in depth than we would in another class. So here's another one where we have the directrix. Here's a sideways parabola. And then we have the focus here, and the vertex is here. Here's our axis of symmetry or line of symmetry. It's called both. The distance from any point, so basically, here's the focus, and here's a point on the parabola. That distance there from the focus to that point should be the same as the distance from that point to the directrix. That's this here. So that should always be the same as that. And using that, we can actually come up with an equation for the directrix, or for the actual parabola itself. And so we have the distances here. This is the distance from the y-axis to point A. So y-axis to point A. And here's the second distance. Anyway, you can see we can square both sides, FOIL it, and we end up with this piece here. Now, this is specifically for a sideways one because the y is being squared in this case. A is going to be the distance from the vertex to the focus. And the focus is always at a comma 0. And the directrix equation, because in this case, it's a vertical line here, is x equals negative a. All right. So parabolas, introduction, part 2. So here we go. Again, we have the equation y squared equals 4ax. But the distance from the focus, from the vertex to the focus, is the distance of a. And the distance from the vertex to the directrix straight to it is the distance of a as well, on the opposite direction. If a is positive, the parabola opens to the right. If a is negative, the parabola opens to the left. And it's up when we're in this form. So here's the form when it's up and down, which you're probably more familiar with. If a is positive, it opens up. If a is negative, it opens downward. And the equation of the directrix is y equals negative a. The coordinates is 0, comma a. And I want to jump through this a little bit. So if the vertex is not, this is when the vertex is at the point 0, 0. When that's not the case, we have our equation is either here or here, depending on. These are up and down, these are left and right. If a is negative, it opens to the left. If it's positive, it opens to the right. If a is negative, it opens downward. If it's positive, it opens upward in this case. All right. So we're going to find the equation of a parabola here in just a moment. So remember that the distance between the vertex and the focus is equal to the distance from the vertex to the directrix, like straight to it. So here are 4 cases. When A is positive and we're here, it's upward. There's a little focus, and there's a little directrix vertex there. So that's the first case. The second case, this one here, is going to be where it's downward. Focus there, directrix there. This case here is going to be where A is positive. This is going to be to the right here, but focus here, directrix there. When A is negative, it's going to be going this way, focus there, directrix there. Right. So let's actually come up with some equations of parabolas. So we're going to start with the first one. I'll do A here to save some space. We have a focus at 7, 0 and a vertex at 0, 0. So let's maybe draw this. So the vertex is here, and the focus is here at 7, 0. So our parabola is going to look something, focus is always inside the parabola, as it were, look something like this. So if we go back to our other cases, this is a y² one at 0, 0, where A is positive. It's opening that way. Let's see here. So it's going to model this here, y² equals 4ax. Y² equals 4ax. And it looks like A in this case is 7. That's the distance from the vertex to the focus. So A in this case is 7. So it looks like we have y² equals 4 times 7x. Here's our equation. Yay. Part B. We have a focus at 0, -1, and a directrix line. So let's try to draw that a little bit. Get an idea of the shape. Focus is at 0, -1. That's down here. Directrix is the line y equals 1. So we're here. That means that our vertex is at 0, 0. And it looks like we're going to have a graph that's doing like this. And that is our scenario here. And we're centered at the origin. And it looks like A is 1 in this case, because the distance from here to here is 1. There's also 1. So I think A is 1 in this case. I should say -1 in this case. Here, -1. And so that's going to give us x² equals 4 times -1y. X² equals -4y. There's our equation. Part C. We have a directrix at x equals 7. That means it's a vertical directrix. And a vertex at 4, 0. Let's see what that looks like. A little bit bigger for this one. So directrix at x equals 7. So this will be 7 here. So here's our directrix. And our vertex is at 4, 0. So we're here. This is at 4, 0. And so it must be opening this way. So it's doing this. So we know that the distance from here to here, trying to figure out where to write that in. So again, the vertex is at 4, 0. And so the distance from 4 to 7 is 3. So A is going to be 3. -3, pardon me, because we're going backwards here. This means we're going to be using this, y minus k squared equals 4a x minus h. And a in this case is negative. We can see it's back here. So it looks like a is -3. Now, k is 0 in this case, right? So y squared equals 4 times -3, and then x minus 4. Here we are. All right, part D. Vertex at 0, 0, that's nice. Axis of symmetry is the y-axis. Okay. So that means axis, and it contains the point 5, 3. Okay, so we are looking at it looks like because the y-axis is looks like we are here. And it contains the point 5, 3. So we are looking at this scenario. So because 0, 0, we're looking at x squared equals 4ay. And I'm going to go ahead and plug in my x and y that I know is on here. So 5 squared equals 4a, and y is 3. So it looks like we are right here. A equals 25 over 12. Putting that all back together, we have x squared equals 4 times 25 over 12y, and that reduces to 25 over 3y. There's our equation. All right, let's explore a little more with these parabolas. Find the vertex, focus, and directrix of each parabola. The vertex is going to be 0, 0. That's no problem here. We need a, and we know that y squared equals 4ax, and if 4a is equal to 4, like it is here, it means that a equals 1. So that means that the focus, this is vertex, focus, because this is positive here, it's going to be opening to the right. The focus is going to be at 1, 0, and the directrix is the equation x equals -1. So here are our answers. B, vertex, that's easy. Remember, it's the opposite signs here. So this is going to be -1, 3. 4a is going to equal 12 in this case. So a is 3. So it looks like our vertex is here. That means our focus is at, I'm going to add 3 to that. So that's going to be 2, 3. And the directrix, and so I'm going to be subtracting 3 from that. So that's going to be x equals -4. All right. Let's graph some parabolas. All right, part A. Part A, we're going to have to do some algebra. I'm going to do some, complete the square minus 10y. equals negative 4x minus 25. And to complete the square, I'm going to take that negative 10, I'm going to cut it in half. It's 5 squared, that's 25. So I'm going to add 25 to both sides of the equation. Squared minus 10y plus 25 equals negative 4x minus 25 plus 25. Very nicely, those go away. We now have y minus 5 squared equals negative 4x. So it looks like we're going to have a vertex at the point 0, positive 5. This is going to be opening to the left, so negative 4 equals 4a. That means a equals negative 1. All right, so let's put all this together. So we're at 0, 5. Here's our vertex. So our parabola is going to look something like this, with a focus at this point here, which is the point negative 1, 5. Vertex here is, and then we are going to have the directrix is the vertical line x equals positive 1. All right, part B. Part B. Oops, too far. Part B. All right, we have a vertex, looks like. Vertex at the point 5, negative 1. Looks like 4a equals negative 1, so a equals negative 1/4. That means that it is opening downward, it looks like to me. So let's go to the vertex. Ooh, barely fit that in. Vertex in this case is 5, negative 1, so we're here. It's going to be opening downward. It's going to be quite wide. And the focus, so the focus is going to be, see, that's going to be negative 1 minus 1/4. So negative 5/4, and then here it's going to be negative 3/4 for the directrix. I'm not going to try drawing in, that's too bad. But there it is. If you want the specific points, you can always make a table. All right. We have the reflector of a flashlight in the shaped paraboloid of revolution. Its diameter is 4 inches, and its depth is 2. So let's draw this scenario. So we have a paraboloid, and this diameter this whole distance here is 4. Now, if we make this 0, 0, that makes this point, and this is a distance of 2 here. And that also makes this a distance of 2. Since the whole thing is 4, that's a 2 there, and that's a 2 there, which makes these points the point 2, 2. This point here is negative 2, 2. And what we can do is come up with, this is this scenario here. And we're looking for A. So I'm going to stick, we'll use this point, may as well. This is going to be 2 squared equals 4a times 2. So that's 8, that's 4. So A, it looks like, is 1/2. So how far will it be? To the focus, it's going to be a 1/2 inch away. So it's going to be about right there, and then you're going to get that nice brightness that you're looking for with a parabola. Good stuff.